Example 1. A sample of 11 circuit from a large normal population has a mean resistance of 2.2 ohms. We know from past testing that the sample standard deviation is 0.35 ohms. Determine a 95% confidence interval for the true mean resistance of the populations. So our first step is we need to understand which situation we're in, because we have three situations right now. The first situation is we have the population mean with population standard deviations. The second situation is we have population proportions. And the third situation, the new situation, is population mean with sigma unknown. And this is the situation that we're in right now. We're in the third situation. We don't know the population standard deviations. And how we know we're in the third situation is because we're given sample standard deviations. We're given sample standard deviations. When we're given sample standard deviations, that means we don't know the population standard deviations. So that's why we know that we're in the third situations. We're in the t distributions. And once we know that we are in the third situations, then we know that we're dealing with t distributions. That's the first step. You need to know which situation you're in. We're in a situation where we have the population mean with sigma unknown. So we're given sample standard deviations. Once we know which situation we're in, then we draw the diagram. So we're looking for 95% confidence interval. So therefore what we're looking for is x1 and x2. And this is the normal distribution curve. And we know that the population mean is 2.2. And we're looking for x1, x2. So that means we have 95% in the middle, because we're looking for 95% confidence interval. So 95% in the middle. So then what that means is that we have 2.5% on each side. Because we take 100% minus 95%, that means we have 5% on both sides in total. So we divide that by 2, we get the 2.5% on each side. And that's your alpha over 2. Once we have drawn a diagram, once we understand the diagram, then our next step is to solve for the confidence interval using the formula here. So the confidence interval for the t distribution is x bar plus minus t alpha over 2 times s divided by square root n. The reason we're using this formula here is because for t distribution, Excel does not have a single formula that we can use to get x1 and x2 directly. So therefore, we need to use the confidence interval formula algebraically. For normal distribution, for z distribution, we can use the norm.inv formula to get x1 and x2 directly. But for t distributions, Excel does not have one single formula that can directly help us get x1 and x2 with the t distribution. So therefore, we need to use the algebra here. And in this algebra here, our point estimate is the x bar. X bar is your 2.2, that's your mean. And then we have plus minus, and then we have the t critical. T critical is your t alpha over 2. And the formula that we're going to use to calculate t critical is t.inv. And they will ask you for two variables. The first variable is your probability. So probability is your alpha over 2. That is your probability to the left of x1. So that's why we have the 2.5% here, 0.025. And then your degree of freedom is n minus 1. So n is 11. So 11 minus 1 will give you the 10. So that's how we get a degree of freedom, n minus 1. So again, the t critical asks you for two variables. The first variable is your probability. Your probability is your alpha over 2. That is your probability to the left of x1, the 2.5%. And then your degree of freedom is n minus 1. So 11 minus 1 will give you the 10. So I'll show you that in Excel right now. Equal t.inv, open bracket. It asks you for the probability. Probability is 0.025. That's your alpha over 2. And then we have your degree of freedom. Degree of freedom is your 10. And then we close your bracket. And then you're going to get negative 2.228. And that's your t critical. So once we have calculated the t critical, we can substitute that into the formula, negative 2.228. And then we have the sample standard deviation S. S is your sample standard deviation, which is 0.35 ohms. So that's 0.35. And then we have square root n, which is your square root 11. So once we have all these variables, then we can plug it in to solve for x1 and x2. So we have two equations. One is for the plus, the other is for the minus. So that's why we have 2.2 plus the t critical times your standard error, and then we have 2.2 minus your t critical times your standard error. And how do you know which is x1 and x2 is based on the answer that you get. X1 is always going to be the smaller number, And then x2 is always going to be the larger number because x1 is your lower bound, x2 is your upper bound. So the smaller number that you get from the plus minus will be your lower bound, and then the bigger number will be your upper bound. So in summary, when you're solving these questions, your first step is understanding which situation you're in. You need to know which situation you're in because now we have 3 situations. So your first step is to identify which situation you're in so you can use the correct formula. And in this question, we're in a situation where we have the population mean with sigma unknown. The reason we know that we're in this situation is because we're given the sample standard deviation. We're given S. When we're given S, that means we don't know the population standard deviations. So therefore, that's how we know we're in this situation. And in this situation, we're going to use the t distribution. So whenever we don't know the population standard deviations, that means we need to use the t distributions. And that's your first step, understanding which situation you're in. Second step is drawing a diagram so you can visualize what is going on. And then third step is that we know that we're looking for the confidence interval, so we can use the formula provided in the formula sheet. And you know that there are 4 variables here. 3 of the variables are given, so you know the x bar is your sample mean, which is 2.2. You know the s is your sample standard deviation. You know the n is your 11, that's your sample size. So from these 4 variables here, you have 3 of the variables already. The only variable that you're missing is your t critical. T critical, how we calculate that is t.imv, which will ask you for 2 variables, your probability to the left of x1, and then you have your degree of freedom n-1. And again, the reason why we have to use this formula here to calculate the confidence interval, to calculate x1, x2, the reason why we need to use this formula algebraically is because Excel does not have one single formula that can directly help us get x1 and x2. In previous chapter, we used the formula norm.imv, and that formula can directly help us get x1 and x2, and that's only for the normal distribution, that's only for the z distribution. But for t distribution, it doesn't have that formula in Excel, so therefore we have to use the algebra here. And that's the concept that you need to know for this example.